Okay, so the third video that we're going to be looking at is, well, in cases where we can't actually solve one of the triangles that we've been given, okay? So in some problems, there are triangles that can't be extracted from 3D models. So like when you're drawing your picture and then you're taking out your triangles, you can't actually solve any of them for any values. To solve these, what we're going to do is we need to introduce a pronumeral for the height, then work around the figure until 4 measurements are known in terms of whatever the height value is. With h, we'll call it h in this case. At this point, an equation in h can be solved and formed. And this is actually really clever because you kind of use facts that don't really sort of make sense, or like, you sort of use things where they don't really work, and you use parts that aren't related to the thing you're trying to find, and you find it. It's really interesting, I think. So let's talk about this example, and I'll show you how it's done. So a motorist driving on level ground sees due south of her a tower whose angle of elevation is 15 degrees. After driving 5 kilometers further in a straight line, the tower is in the direction due west with an angle of elevation of 11 degrees. Okay, so let's draw a situation of what's happening. Okay, so here's a tower. Okay, I'm going to call the base of the tower B and the height of the tower T. And we don't know how high it is, so I'm going to call that, well, actually, let's not even worry about that just yet. Okay? Now, we know that when she is south, okay, so when she is south of this tower, she looks up at it, and there's an angle of elevation of 11 degrees. Okay? So let me do that a bit nicer, actually. So when she looks up, so in there, it's 11 degrees. Okay, and at that point, she then drives 5 kilometers more until she gets to a point where she is exactly west of it. And then when she looks at the tower, when she's west of it, the angle of elevation is... when she's south, it's 15 degrees. And when she is west, it is 11 degrees. And we know that when she drove from south to west, she travelled 5 kilometers. Okay. So there we go. So, part A asks us, how tall is the tower? Now, looking at this, we can start to try and solve some of these triangles. So we've got 3 right angle triangles. Okay, and we could start using some of this information to try and solve it. So I'm trying to find the height of the tower, so I'm going to call that h. H for the height. Now, looking at this, we don't actually have enough information to be able to solve what the height of the tower is. So we could use some of these triangles to try and work them out, but ultimately what we'll find is that we can't actually, we can't do it. So let's start with this triangle on the southern triangle. Okay, so she's south. Oh, let's make it a bit better actually. So it's something like this. So it's 15 degrees south. Okay, there's the base, there's the tower, and that's the height. Okay. Do we know anything else about this? We don't know the length of this line of sight. We don't know that, and we also don't know how far away she is. And there's no way we can work it out either. Okay, because between the base and south and the base and west, it's actually going to be a different distance away, because the angles of elevation are actually different when she looks at them. So how do we actually work out what this is? Well, okay, to do so, let's have a look at the other triangle, the west and the west of the base. Okay, so the west of the base, I'll do it in the other direction just so we know that they're different triangles. Okay, the base to the west. Well, this one's 11 degrees. Okay, from west to the base to the tower, and we know what the height is. But again, we don't know any of this other information. All we know that between the west and the south is linked by 5 kilometers. So let's draw a third triangle now, and this triangle is going to be the distance triangle between the west and the southern ends. So there's the west, there's the south, okay, and there's where the base of the triangle is. The only thing I know about this triangle is that this length here is 5 kilometers, okay? So that's all I know about these triangles, okay? So those are the 3 triangles I have, that's all I know. So the question now becomes, well, how do I relate the base, so this base, and the south, so that length there between the base and the south, and the base and the west, to come up with a value, or come up with an expression due to the height, okay? Because if I could work out what this and this are, okay, I can then use that in both of those triangles to get a value for h. Okay, so I'm going to actually use triangle 1 and triangle 2 to come up with 2 expressions for BS and for BW. So let's call this bottom one BS, let's call this bottom one BW, so base to south and base to west. Okay, now using trig, we've got h over BS. So what uses opposite and adjacent? Well, that is tan. So tan of 15 degrees is equal to the opposite, which is h over BS, okay? So remembering, I want this in terms of BS. So what I'm going to do is I'm going to take the reciprocal of both sides, okay? Oh my god, it disappeared. I'm going to take the reciprocal of both sides to get the BS on top. Now 1 over tan 15 degrees is the same as cot of 15 degrees, okay? So I'm going to use some of the new trig ratios in this one. And that's equal to BS over h. But I want to get the BS by itself because I'm wanting something in terms of BS. So to do so, I'm going to multiply both sides by h. And this is going to give me h cot 15 degrees is equal to BS, okay? So that means that this length from here down to here, in terms of h, is equal to, in terms of h is in terms of that length, is h cot 15 degrees, okay? Again, we don't know what h is just yet, but we'll find that out in a moment. Okay, so that is for BS. Now we're going to do one for BW. So again, same sort of thing. We've got the h, okay, and we're trying to find this side. So we're going to be using tan. So it's tan of 11 degrees is equal to h over BW. Now I'm going to take the reciprocal of both sides. So taking the reciprocal of tan gets me cot. So cot of 11 degrees is equal to BW on h. Now to get the BW by itself, I'm going to multiply both sides by h. And so that gives me h cot 11 degrees is equal to BW. So this length from here to here, okay, is equal to h cot 11 degrees, which is this length in here. Okay. So let's take this second triangle. I'm just going to redraw it again down here because I'm going to use this triangle now to rearrange and solve for h because I can. Because my ultimate goal is to find the height in which I've called h. But we've got 2 lengths that are related to the height in some way. And what we're going to do is we're going to rearrange this in some way to get the h's by themselves. So the question now becomes, well, how do I relate the 2 side lengths of a right angle triangle with its hypotenuse? And I'm hoping what comes to mind is this formula here. So substituting some values in, we get 5 squared is equal to h cot 11 degrees squared plus h cot, that should be 15 degrees squared. Okay, expanding these out, we get 5 squared is equal to h squared cot 11 degrees squared. Okay, so when you're squaring a sine or cosine or a trigonometric ratio, the squared goes with the function, not like after it. But you can do it both ways, but this is the more proper way. Okay, so this becomes h squared cot squared 15 degrees. Okay, now we're going to factorize this because we've got a h squared in both of these. So 5 squared is equal to h squared lots of cot squared 11 degrees plus cot squared 15 degrees. Okay, and so 25. So well, let's write it this way. So dividing both sides by cot squared 11 degrees plus cot squared 15 degrees, we get h squared is equal to 25 over, okay, cot squared 11 degrees plus cot squared 15 degrees, okay. Now, to put this into your calculator, well, we've got h squared, so this is actually equal to h, so h is equal to the square root of this. But to put cot squared into your calculator, or to put cot into your calculator, because remember, this is just a squaring function, cot is the same as 10, or the inverse of 10. So what we can do is we can rewrite cot, well, that's tot, not cot. So we can rewrite cot squared 11 degrees. So we can rewrite this as cot of 11 degrees squared, okay? And we know cot as, well, cot is just 1 over 10, okay? So we can rewrite it like that. And that's going to help us be able to put it into our calculator. So 1 over 10, 11 degrees squared, plus 1 over, and making sure when you put in your calculator, you put that in brackets, otherwise you might get something that you don't want. And 1 over 10 all squared, okay? Just like that. So, once you've done that, you put it into your calculator, and you should get the height of this tower to be 0.79 meters high. Okay, so this is not easy. Let me get that straight to begin with. This isn't easy. This is hard. This is very, very tricky to do. The whole idea is by saying, well, what do I need to find and how can I relate that in some way? You're going to be doing a lot of diagrams, a lot of pictures, and a lot of scribbles to be able to get one of these answers. But once you've done so, it actually falls out really nice, and you can actually find the height of the tower without actually using the height of the tower in any of your problem. Okay, so let's move on to part B. Now, part B says in which direction is she traveling? So let's do part B over here. In which direction is she traveling? Okay. So, well, we know she's traveling westernly, okay, north and west in some direction. But if I'm asking for a direction and it's trig, I'm asking for a bearing. So her first point where we found out something about her, she was south. And the second thing that we knew about her was that she was traveling west. So at some point, okay, well, sorry, so she must be traveling in this direction, like this, okay? So to do so, we're going to need, so to work it out at what direction it actually is, we're going to have to work out, well, what's that bearing around in that direction here? Or in other words, what's 360 minus this direction here, okay? So what do we know about this triangle? Well, this triangle I've just drawn is the same triangle as this one here, over here. Because that triangle there is this bottom triangle here. And that bottom triangle there is pretty much the one that we're trying to work with. Because we're, you know, she's starting at this point south here, and she's traveled 5 kilometers, and she's reached that point there. Okay? So another piece of information is we know that this part down here is equal to 5. So what we're trying to do is we're trying to work out, well, what the bearing is, okay? Or we can work out what that angle is, minus 360 degrees, okay? Because it's, you know, it's the outside we want for this because it's the clockwise motion that we want, okay? So what else do we know about this triangle? Again, we've only got 2 bits of information. We've only got this thing here and this thing here. We need something else. Well, we do know something else now. We know what this length is here, and we know what this length is here. Okay, so we only actually need one of these lengths to be able to do it because we've already got the 5 kilometers there. So let's use the top one. So we know that the distance between the base of the tower and the western direction, okay, so the base to west is h cot, okay, 11 degrees, as we worked out before. But we now know what h is equal to from back over here. And we worked out that back over here, h is equal to 0.79 meters. So this is just 0.79 times cot 11. Or in other words, something that we're going to work out in a bit. Okay, so to work out this angle now, we're going to use our trig ratios. We've got an opposite, we've got a hypotenuse. Okay, quickly jotting down my trigonometric mnemonic, and I know that's sine. So sine theta is equal to the opposite, which is 0.79 times cot 11 degrees over 5. So theta is equal to sine inverse of all that, because I want to work out what that is equal to. Okay, so theta is equal to, put it into your calculator, and you get that that's equal to 9 degrees. So the bearing must be 9 degrees, right? No, because remember we're trying to find, well, what's the outside? So to do the outside, okay, so therefore the bearing is equal to 360 minus theta, which is 360 minus 9 degrees, rounding it, because when we're doing a bearing, we're wanting a 3-digit number. Okay, and so it is 351 degrees true. If we were asked for a compass bearing, we know the compass bearing would be, so she's traveling in the northern direction, and that would be 9 degrees west. Okay, so either one of those, so or north, 9 degrees west. So with that being said, that's the trickiest problem that we're going to be seeing probably in this, sort of the introduction to trig. With that being said, I'll see you guys in the next lot of videos.